Hey everyone, I'm Raghav, and in this video we will talk about the problems from the Leetcode Contest 389. So this is the first problem of the contest, existence of a substring in a string and its reverse. The problem says that we have been given a string S and we have to find any substring of length 2 which is present like in S and its reverse as well. And we have to return true if such a string such a substring exists, and otherwise we have to return false. So let's see um, an example. Like in the given example, lead code, there is a substring EE which is coming up in lead code and its reverse as well. Like the reverse of lead code is EDOCTEEL. Here as well, EE is coming. So we just have to tell whether there is such a substring in the given string or not. We have to return true or false on the basis of that. Like for lead code, we return true because we found a substring. For ABCBA, there is a substring there is a substring AB which is coming up in AB and its reverse as well. Like the reverse of ABCBA is also AB, and it is ABCBA. So AB is coming up two times. Malab, it is coming up in the string S and its reverse as well. Similarly, like there are some more substrings you can see which are coming up in both of the strings. And in an example like this one, ABCD, we don't have any substring which is coming up in ABCD and its reverse. The reverse of ABCD is DCBA. So the logic is pretty straightforward here. The problem said that we have been given a string. Let's say the string is ABCD. We have to find whether there is any substring of length 2 in this string which is coming up in its reverse as well. So first of all, like whatever string you have, find its reverse. Let me call the reverse as string T for now, or maybe let me call this as S dash, the reverse of S, DCBA. Now, like from both of these strings, you just have to check if there is any common substring of length 2, right? Because if there is any substring which is coming up in this and this, then we will return true, else we will return false. Now, how will you find it out? One thing which I generally recommend for thinking about the process in case of substrings and all is that what you can do is like in a string of length 4, there will be three substrings of length 2, like AB, BC, CD. है ना? There will be only these three substrings. So you can have AB, BC, and CD as the three substrings. Similarly, you can just find out all the substrings in the reverse as well. DC, CB, and CA, and just check if this substring is coming up in any one of these or not. Like if this string DC has occurred in any one of these or not. Just check it out. Similarly for CB, similarly for CA. Just check this thing out for every one of them. If you find any one of them coming up in both of these, then you just found a common substring in the string S and its reverse. So you will return true, else you will return a false. Let's take one more example. Lead code. The like in lead code, the substrings are LE. Let me just write up all of them like this in an array: LE, EE, ET, TC, like LE, EE, ET, and then TC, and then CO, OD, and DE. Right? These are the substrings in lead code of size 2. And find out the reverse of lead code. It is EDOC TEEL. And now in this, just find out all the substrings. So you have a substring ed, you have a substring do, you have a substring oc, you have a substring ct, ee, te as well, and el as well. And you see that ed is not coming up anywhere, so this substring is not coming. Do is also not coming anywhere. Similarly for oc never came up in this area anywhere. Similarly for CTTE, and then you will see for EE it is coming up here. So you will just return true because you found at least one substring, at least one such substring which is coming up in the other as well. So like this is the way you can solve the problem, in which you can solve the problem. Here we are, if you have a string of length n, then you will have n minus 1 substrings of length 2. This is something you can figure out why. Like you can try to just visualize this, that if you are picking up two elements every time, you will have n minus 1 possible positions for starting a substring of length 2, because you cannot start the substring at the last place, or visualize it in any way you want. Basically, in a string of length n, you will have n minus 1 substrings, and in the reverse of this string, it would also be a length n string, right? If a string is of length n, then its reverse would also have a length n, and it means that it will also have n minus 1 substrings. For each one of them, you are traversing the whole array, so you are having big O of n time complexity for each and every substring. Basically, you will have big O of n squares time complexity in total, because you are repeating this process n minus 1 number of times. This thing can actually be optimized with the help of a set. You can create a set of strings. If you know about sets, you can use this, but it's not really required here. The problem has really small constraints. So for a beginner friendly approach, I have written it using vectors. If you know about sets, I would recommend you to use sets. So like what I have done here is I created an array, or basically a vector, in which I pushed up all the substrings of length 2. This, like, look at this, s dot substr. Like this is an STL function, or maybe like not maybe an STL. Yeah, actually an STL function. Uh, Sorry, not a function, but a method of strings. Like if whenever you create any string, if you have a string str, then like as we use str dot length to find out the length of the string, you can simply say str, like whatever is the name of the string, dot sub str, this is the name of the function, and pass on two parameters. The first one is the starting index. Like if you want to find out a substring from a string, then pass on the starting index and the length of the substring you want. If you don't pass on the second parameter, length, then it will take up the complete string starting from this index. And like this is just, I'm just telling about substr function, a little bit about it. You can search more about it on internet. And if you want, like if you don't want to use substr, if you want to solve the problem without it, you could have actually written it in a few lines, maybe something like string str equal to empty, then str dot push back si, and then si plus 1, just push back that, just push it back like this. It's up to you. If you want, you can write it in this way, or just use the substr function. It's good to learn about it. Then like okay, so in the code we have seen till this part, we had the string, we created an array in which we just put up all the substrings. After that, um, we reverse the string. Here it is, we have reversed the string, and then for each and every substring of this reversed string, we are first of all finding the substring, and then we have been checking if this thing is like present in the array, if this is present in the array or not. So if you were using a set, in that case you would have inserted the elements here inside a set instead of an array, and instead of running up a for loop, you would have just used a set function to check whether the string is present or not in big of log n time. Here it is taking big of n time. So let's see the time complexity and space complexities. The time complexity here, like for this process, will be big of n, right? It would be big of n, and the space would also be big of n, because we have been storing almost n strings, basically n minus 1 substrings of length 2 inside an array. So it will take in order of n time and in order of n space. Then we have been reversing. It will take big of n time and after that we have been running up two for loops, so it will take go of n square time, n into n time, and it is not really taking up any extra space, so space complexity here will be big of 1. So overall time complexity is big of n square, and the overall space complexity is big of n. Time is big of n into n, and space is big of n, right? So now let's see the second problem. I hope that this problem is clear. By the way, I would like to have your feedback whether you guys want me to describe so much for the first two problems, or just directly go up with it in the normal way. Like I explained almost everything here, even small details, even the very small details. Thinking that if somebody could not solve this problem, then it's good to know. Like for that guy, it's good to know about these things. Let's come back to the second problem. Count substring starting and ending with given character. We have been given a string s and a character c, and we have to return the total number of substrings of s, the given string s, that start and end with the character c. So it's like we have been given some string. Let's say a string like this one. Just I've just drawn a bar for it. There will be some characters here, maybe something like a b c d whatever. Or maybe let me take just one example here. If there is a string like ABADA, ABADA, and the character C is A here. S, this is the given string S, and you have a character A. Then all the substrings like ABA, ABADA, or ADA, these substrings will actually be the ones which start with A and end at A, whereas the substrings like BA or BAD or AD or BADA, these kind of substrings will not be the ones which we want to count. We want to count only those which start with A and end with A, right? Actually, there will be more than three. One of them ABA, the other one can be ABADA, the other one can be ADA, and then the substrings like simple A having starting from here and ending at here, the string A which is starting and ending at this position only, and the string which is starting and ending at this position, that is also A. All these substrings will be the ones which we count. For now, let us call them as good substrings. For now, we will call them as good substrings which start and end at C. Okay. So I think it's also a pretty simple problem. Let us say, like, let me take a very general string. This is, let's say, a string in which there can be any character. So maybe let me draw it like this. I'm just drawing some blanks. There can be any character at these places. And let us say whatever character which we wanted to have a C, this is the string S, is coming up here, 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 and here. I'm just taking up a very general example that you have a string in which at which the character C is coming up here, 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 and here. First of all, ask yourself a question. Do I really care whether there is a character or B or C or like whatever character here at any of the other places, as long as I know that this is not a character C? You will realize that hey, I don't really care about it. Like if in this problem, instead of D, I had a B, or if I had a E, or if I had a Z, like whatever I had, I don't really care about it. As long as this is not A, right? I was searching for the character A. So as long as it is not A, I don't really care which character it is at any position where you don't have A, right? So we only care about the places where the character C is coming. For all the other places, we have seen that we don't really care which character is coming up. So we will try to think in this perspective only. Um, Now I think that, and like now I know that it's something very simple which I described here, but it's good to focus on these kind of things also. Sometimes you might just ignore this kind of small detail, that whether I care about the other positions or not, and at the end you might realize that if you had focused at this thing, you might have been able to solve the problem earlier, like faster. Let's come back. We have seen, let's say that C is coming up at these positions. Now we have to just find out how many substrings can there be which start at the character C and end at the character C. So how many substrings will be there which can start at this place and are good substrings? Like how many good substrings can start at this index? One of the substrings can be this one only, starting and ending at C. Other substring can be starting here and ending here. Like this can be a very good substring. Then something like this can be a good substring, and this can be a good substring. All the other substrings which start from here and end at any place other than these four will not be a good substring, right? Probably you would have noticed the idea that for an index like this, the good substring starting from this index will be the count of, or maybe the frequency of C, or maybe you can just say frequency of stri, if the string name is s. So the frequency of si, um, see, let me describe something. Let's say that this is index I. Then in that case, the number of good substrings starting up from this index will be um, equal to frequency of C in the substring from index I to n minus 1. Basically, what I have said is the frequency of C starting from this index till the end. Like, let's say if C is coming up 4 number of times, then you will have 4 possible substrings which start at this place. If C was coming up 10 number of times, then you will have 10 substrings which are starting from this place in this complete string. Sorry, which are starting from here. Hai na? There will be that many substrings. So what you need is you just want to know about the frequency of C in this substring. Then for this guy you want to know about the frequency of C in this substring. Then for this guy you want to know about the frequency of C in this substring, and for this guy you want to know about the frequency of C in this substring, and so on. Right. This is one way. The other way of thinking it can be, let us say if C is coming up at these places, then one other way of thinking can be, or maybe let me move this one, the number of substrings which are ending at C, like this, the number of substrings which are ending at this index, that will be equal to, let me take up example here, the number of substrings. Let's say if you want to find out the number of substrings which are ending at this position, it would be equal to the number of times C has occurred so far in this prefix of the string s, right? Till this point the number of times C occurred. From that many positions you can start a substring which can end here, right? These are the three substrings which can end here. So like this is the exact same thing which we had been doing here. It's only the only difference is that here we were talking about starting and here we are talking about ending. But the main thing is, uh, when you will implement, I think that for a beginner this one will be easier to write. What you have to do is, like, at least think, I think that thinking this one would be easier for a beginner. That's why I have been discussing this way. So now what we have to do is, we have a string s. We can just find out all the places where C has been coming up. Now for the first time when C comes, like whenever C comes for the first time, this is the first time when C is coming, there is only one occurrence of C in this whole substring. or this whole prefix. So you will have, like in your answer, you will add 1. Initially answer was 0, now you will add 1 into it. Then the next time when you encounter a C, you will have two number of C's in the prefix, right? Obvious thing. So you will have two number of substrings which can be uh, created such that they are ending at this C and they have been starting from some C. Then for the third occurrence of C in the given string, you will now have three substrings which can end at this position, because there are three starting position and you have fixed this ending position. So you will have three being added here and so on. So if C was coming up X number of times, then you will actually have, like you can just see that the pattern will go on till X. So at the end you see that the answer is nothing but the sum of first X natural numbers, where X is the frequency of C in the whole string. So we just have a formula for it, X into X plus 1 by 2. For now we can use this formula, but in case if like I will give you a follow-up problem for here. Like in this given problem, we had to find out the number of substrings which are starting at the character C and ending at the character C. Let us say if the problem said that they are starting at character C and have been ending at character D. If you had been, instead of being given just one character C for both starting and ending, if you had been given these two characters that a string should start from C and end at D, then in that case you might not really get such a good pattern, but the idea in which we have been solving will still work. In that case, every time you find out a D, which is basically the ending position, whenever you find out a D, you will look up for, whenever you find up a D, in that case, you will look up for the frequency of C in this prefix. The frequency of C till now and the frequency of C till now, for which you can just create a variable with name, say, let's say frequency of C being initialized with 0 and being incremented later on, or maybe name it as count, whatever you want. Just name it whatever you want, and the idea will still work. So I would recommend you to try out this follow-up problem as well. In the original problem, we had been told that we have a string and we have been given some character C, and we want to find out the number of substrings which are starting at the character C and ending at character C. In the follow-up problem, I'm saying that these strings, you have to find out the number of strings which start at character C and end at character D. Right? Like try to think about that problem also. For now, in the problem which we have got, we saw that we just got a really good pattern from which we just found out some the answer directly. Here you just have to find out the value of X, and from there you can just say your answer is equal to answer into X plus 1. In the other way, like I'm just giving you some hints for the other way, this is also a standard problem. You will probably get some good solutions online about it, and maybe some place where you can try to submit the problem. In the other approach where you wanted to have a string starting from C and ending at D, for that thing you could have maintained two variables, answer being initialized with 0 and count being initialized with 0. Every time you find a C, you could just increment the counter that you have found a C, and every time you find a D, you could just increment answer by C and D, that there will be this many substrings which will end, which can end at this place. In that way you could have done for the follow up. I'm not writing up the complete code for that. You can search for that problem online, you will probably find it out. Now for now, let's see the problem B, the original problem. We have been given the string S. I'm just finding out its length, then I'm finding out the count. Like I just initialized a variable with name count and incremented count as many times as I found C. So in the CNT I will have the frequency of C. Then I said that answer is nothing but it is equal to CNT into CNT plus 1 by 2. And even if you think about it logically, um, even if you think about it like this, um, you have some positions and uh, there are some characters in between, but we will never have them as the starting or the ending character. So you just have some starting, some like some positions from which you can start and from which you can end. So finding out the number of such substrings which will start from one of these and end at one of these is something similar to, like, finding out that count is something similar to finding out the number of subarrays in an array of size n. Let's say you have been given an array of size n and you want to know how many total subarrays can be formed from it. The way you find it out there, you can just find out the count here as well in the exact same way. Obviously this is something not important, like probably you already know about it. Let's come back. We just counted the answer and we just returned it. We have not really used any um, extra space, like we just have used some constant extra space, some integers, so it's fine. And for the time complexity, we have been using a for loop of size n. So the time complexity is big of n, time is big of n, and space is constant, so we can call it as big of 1. I hope the problem is clear. And this is, like, let's move to the second problem, sorry, third problem. This is the third problem of the contest: minimum deletions to make strings k special. Now here I won't really discuss about the very small details as I have been doing in the first two problems. I expect that if you are coming up to the C problem, you are not really a very beginner, like you're not a complete beginner, you have some experience. So let's see. The problem says that we have been given a string word and an integer k, and we consider word to be k special if the frequency of word I minus word j is less than equal to k for all the indices I and j in the string, and frequency of x denotes the frequency of the character x in the word, and absolute of, like, this is denoting the absolute value of y. We have to return the minimum number of characters you need to delete to make the word k special. So let me draw it here. You have been given some substring. You have been given some string. Let's say AAB, CABA. Let's say this is the string which we have been given, and here k is equal to 0. This is, let's say, str. Instead of word, I am using the word str. So here, the first question which you should have: does it really matter in which order these strings are? Like, do I have to do anything with it? Do I have anything to do with the order of elements? You will see that you just have to do stuff with the frequency of the elements and nothing to do with the order of elements. So instead of remembering the complete string, if I just remember how many times A has been coming, like A has been coming 4 times, B has been coming 2 times, and C has been coming 1 time. If I just remember this much, whatever answer I get from here will be correct for this guy, right? Even if the string was something like A, even in that case, the answer, like the answer of this string and the answer of this string, will be equal. How do I say this? Just imagine that you got your answer by deleting some characters, maybe like C, A, and this A from this substring. Then let me use a different one. Let's say for getting the answer in this original string, you deleted this A, this C, and this A. Then in the permutation of the original string, in some permutation of the original string, you will just have different positions for those characters which you erase, but you can still, like, if you erased an A and an A here, you can just erase the two A's and a C. At the end of the day, the remaining string you will have here contains two A's and two B's. It also contains two A's and two B's. So, like, this is a really common observation which we can make. Like, generally a lot of problems have this observation, which makes the problem a lot simpler. And here as well, the problem has got a lot simpler. you don't really have anything to do with the original string, like the order in which the elements have been coming up in the original string. All you need to do is just keep track of the frequencies of all the elements. So for now, we will say that whatever input we got, from there we will just find out. We will create an array, let's say cnt, or I think that I named it as frick. Frick is telling me about, basically this is the short name of frequency. Frick of, let's say frick of 0 contains the frequency of character A. Frick of 1 contains the frequency of character B. Frick of 2 contains the frequency of character C, and so on till 25, which contains the frequency of Z. Let's say I create a frequency array like this, and in that I will just store the frequency of each and every element, right? So here the frequency of A is 4, so I will just say here frick of 0 will be 4. The frequency of um, B, which will be fric 1, will be equal to 2, and fric of 2 will be equal to 1. I can do something like this to find out the frequency of each and every element in the given string. After that, like now what I have to do is I have to reduce, like in one operation, since we have been told that we can delete elements to make the word case special. Deleting a character, like if I delete A, what it will do is it will just reduce the frequency of A by 1, right? So I can say, I can just think of the problem as I can use one operation to reduce the frequency of some element. Reduce the frequency of some element, right? And I have to apply minimum number of operations. Minimum number of operations. This is my goal, such that let's say yeah, such that the absolute difference of frequency of any two elements is less than equal to k. Like from A till Z, if I choose any two random characters from of my choice, any two random alphabets, let's say C1 and C2, or maybe let's say if I choose B and O, then the frequency of um, B minus the frequency of O and its absolute value, basically the absolute difference between frequency of B and O, should be less than equal to K. And this thing should not be true just for B and O. Instead, it should be true for all the characters, let's say C1, C2, for all C1 comma C2 belonging to A to Z. Basically for all the lowercase uh, alphabets, for all lowercase English letters. This thing should be true. And if you look at the example, here we have k is equal to 0, which means that absolute difference should be less than equal to 0, which means it should be equal to 0 because absolute difference cannot be less than 0 anytime. So what we want to do is we just want to make all the frequency of all the elements equal. Here it is indirectly saying this thing. So how will you make the frequency of all of the elements equal? Tell me one thing. If you have A coming up 4 times, B coming up 2 times, and C coming up one number of times, can you increase the frequency of one? Can you increase its frequency? No, you cannot increase it. Or can you increase its frequency? No, you can't increase anyone's frequency. For this 4, yeah. So, oh yeah, there is one more thing which I just forgot to tell. Let us say I reduce the frequency of C to 0. Then in that case, since C is not like frequency of C in the string is 0, it means that C is not coming up in the string. So I will have only these two characters left whose frequencies I want to make equal. So I think they would have mentioned, yeah, frequency of X denotes the frequency of character X in the word. Uh, no, sorry, it was this thing that word I, like word I, if you say word I, it means that you're talking about a character which is coming up in the string, right? Similarly, word J is a character which is coming up in a string. So like the if you just try to read the original constraint, I think it should be doable for you to understand कि we only care about those characters which are in the string after deletions. If the string look like A, B, B, C, and I delete C from it, and let's say I deleted A and A from it, then I have only A, B, B left. So I will compare only the frequencies of A and B. I will not compare the frequency of C because this is not available in C anymore. Now, I don't really know, like at this step, I don't know whether reducing the frequency of A will make more sense or reducing the frequency of B will make more sense. Let's say if C was not there, and when C is there, I don't even know about C. Here, should I reduce its frequency or its frequency or its frequency? Let me take a simpler case where it will be more clear. Let us say A is coming up 5 times, or maybe let's say A is coming up 3 times and B is coming up 2 times, and K is equal to 0 for now. I'm just taking up a very simple case. So try to think of what should I do. Should I reduce A's frequency till it becomes equal to 2, or should I reduce B's frequency until it becomes equal to 0? You will say that hey, it makes more sense to reduce the frequency of A such that so that the frequencies become A is equal to 2 and B is 2. Right? You will say this thing. It makes sense here. But what if the given array was A is 5 and B is 2 and K is 0? Like, what if these were the given inputs? In this case, it would be better to make like A remain 5 and B becomes 0. Right? It will be the best thing you can do. It will take two operations. Help us, one. In this case, if you like do the exact same thing which we were doing earlier of making the frequency of A become equal to B, then it will take three operations, which is not really the best thing. The best thing which we can do is just remove B entirely. So I think it does make sense key for a character with smaller frequency, either I will remove it completely from the string, basically make its frequency equal to 0. I can even avoid it writing it here. I will have only A's in the string with frequency 5n, or reduce the frequency of the larger, like of the character with a bigger frequency till it becomes equal to the one with the smaller frequency. Hana, something like this you can do. So try to first of all think about the solution with k is equal to 0. What will you do? Later on we will try to identify what if the thing is other than k. At the very least we have seen here we can't decide on one way key should I reduce its frequency or its frequency. Like whether should I reduce A's frequency or not actually depends upon B's frequency as well. If B's frequency was equal to 4, in that case I would have reduced A's frequency. If B's frequency was equal to 1 or equal to 2, in that case I would reduce B's frequency. है ना? So I can't easily decide anywhere. So like what I am trying to tell here is all the greedy ideas which we have been getting, the greedy ideas which we have got so far didn't work out, didn't really work out. Or to be honest, we didn't even get any solid greedy idea. We just directly saw that this greedy thing is not working. What if I just reduce this guy or reduce that guy? It depends upon the other's frequency also. Tell me one thing. Let us say A's frequency is 5 and B's frequency is 2. If the total number of characters here is 7, I know that at the end of the day, for the case when k is 0, like whatever I do, A's frequency and B's frequency, either these things will be 0 or some number, let's say x. Similarly, for the other person, either it would be 0 or it would be some integer x, right? from what we have seen above, can I say this thing? Here, I don't really know here on which elements how many operations I will apply. But at the end of the day, like right now for two characters, you might feel that I will just look up for others' frequencies. But what if there were 26 characters, all of them present? C is coming up, let's say seven number of times. Hana, if you had this kind of stuff as well, in that case, you can't really check up everyone's frequency and try, once you can just try if you are able to get any greedy ideas. I don't think it will work. So there is one different. This is also a standard thing, a very common way of simplifying the problem. Try to like you don't really know here whatever state you have here. You have the frequencies of A and B. Maybe you had some frequency of C also 7 here. You don't really know on which character how many times I will apply the operation. But at the very least, you know one thing. Key in like whatever I do here. Let us say you did something here you like right now you don't know what is best for you to do, but let's say you did something, um, and you did the best case, the best possible thing you could do. Let us say you have done it. Then at the end, what will you have? You will have the frequency of A being either 0 or x, some integer x. For in B as well, there will be either the frequency will be 0 or it would be something. And for C, it would either be 0 or it would be x. Obviously, you would have noticed that if the frequency of A is not 0 and it is x, and the frequency of C is also not 0, then they must be equal. है ना? I've just written it in this way to say that whatever characters still remain, their frequency will be equal. I don't know how I will get to the state, but if I somehow get to know about the value of x, can I find out what will I do? Right now, I don't really know what will happen here. I don't really know on what characters should I apply the operation. But if I somehow knew here at the end of the day, I will have x or like 0 whatever characters remaining in ABC possible characters, then can I figure out what operations should I perform? Let us say if I know here the value of x here is 5. Let us say it is 5. In that case, I will not make any operations on 5. For C, I will make it equal to 5, because like you have only two choices, either make it equal to 5 or make it equal to 0. Making it equal to 0 is just like right now we are able to use this much of our brain here. We can greedily decide if I apply 7 operations on C to make it 0, or if I apply only 2 operations to make C equal to 5. This one is better, right? It will take only 2 operations. And for 2, I can't make it equal to 5, so I have only one choice, let make it equal to 0. So apply 2 operations on B to make it equal to 0. Right? Did you get the idea? Did you get the idea? That if I somehow know, like this is something similar to what we do in binary search. In binary search, we don't really know what to do right now, but we just try to identify that what if we knew the answer, could you find out something? Like in binary search, I don't know how to find out the square root of a number, but I identify कि यार if let's say I chose a number k, I can just compare k square with x to decide whether I have like whether k square is greater less, like on that basis I can decide whether I should search on the right or left. You are if you see here you are just checking for some values until you get to our answer, right? Now I'm not really going it in a lot of depth for binary search, but it is something similar to binary search on answer. Binary search on answer. I hope that you are able to relate with it. At the very least, I do relate it with it in that way. Now the question is, how will you get this x equal to 5? How, like right now we just identified that if you fix some value of x, can you find out the best possible answer to get to the state? But you don't really know what the value of x is. But you know one thing, the value of x can be like it would definitely be greater than or equal to 0. Indeed, it would be actually greater than 0, but let's say it can be equal to 0, like just say yeah, it would be greater than equal to 0. For any of those values you can find it out, as long as x is less than equal to 7 or n. Basically what I said is x will be in the range from 0 to n. This x will be in the range from 0 to n. So what if I check for each and every one of these values of x one by running up a for loop? If I just run up a for loop for x from 0 till x is less than equal to n, and for every time I just find out the cost. This is something I already know. I got a string from which I had been given a string from which I found this thing. From there, I didn't know what to do, but I did know here. If I know about x here, like I can just find out the best possible something I can do to make all the elements either equal to 0 or x, if I know about x. So I just said, here, let's brute force through all the values of x, basically from 0 to n. Ki what if x is 0, what if x is 1, 2, and so on till n. And for each and every one of them, I can just find out the cost. We already know how to find out the cost. If like you have 26 characters only, right? Let me write it here. You have only 26 characters, so you can run up a for loop for inside this bigger for loop of x. You can run up a for loop of I from 0 till 26, like less than 26, inside which you can check that, hey, if frequency of I is greater than or equal to x, then what will be the cost? You will just make frequency of I equal to x, so you will have to apply this many operations, right? You will just delete the remaining operations after x. Let's say you have 10 occurrences of character a and you want to have 7 occurrences, then you can delete 3 occurrences, that is 10 minus 3, 10 minus 7. And in the other case, if the frequency of I is less than x, in that case, since you cannot increase the frequency, you can only reduce it. You will have to reduce it till it becomes 0, until it becomes 0. So you will have to add frequency of I, this many, like remove this many occurrences of I, right? That's what you can do. But okay, so now just have a breather, try to think of whether we have got to our solution or not, whether we have actually got an idea ki if k is equal to 0, can you actually find out the solution for any string when k is equal to 0? I believe we can, because we are having a loop of n inside which we are having a loop of 26. So we are having a loop of 26 into n for each and every possible value of x, which can be for each and every possible value of x. We are just finding out the cost, like we will initialize cost with 0 and we will then figure out the cost by running up this for loop. And then we will say your answer is equal to minimum of answer and cost. This is how we can just figure out the um, cost uh, to cost like the cost to have the substring satisfy the given condition for each and every possible x. But now the thing is, the problem did not guarantee k to be 0. It can be something greater than 0. It can be 0, but it can be something greater than 0 as well. So it is still something really similar. Let's say if you are having a is coming 5 times, b is coming 2 times, c is coming 7 times, and k is equal to 1. Let's say if it is something like this, then you know that after some operations, like here you don't know what operations you will apply, don't know about the operations. Let me make it less bold. Yeah, so you don't really know about the operations, but you know one thing, after some operations which you apply, will have the frequency of A being either 0 or something between some Mn and Mx, where Mn, like some range basically. It would be something in some range, let's say from L to R, including L and R. है ना? In simple words, let us say you did something and after that the mx is the maximum frequency of any character. Okay, let me talk about one more. Like this is something basic, but let me just cover it for the sake of a tutorial. If you want this thing, if you want the absolute difference between frequency of every possible characters in the given string to be less than equal to k, you want this thing to be less than equal to k. Um, for this, like what will be the maximum possible value of this guy? For all the possible combinations of C1 and C2, what will be the maximum possible value? It will be in the case when one of these people is having the maximum frequency. Let mx be the maximum frequency of any character in the given string, and mn be the minimum frequency of any character in the given string. So when one of these people is mx and the other person is mx, sorry, one of them is mx and the other one is mn, then in that case the absolute difference between these two will be maximum, right? So if I just focus on um, making, like if I just focus on making mx minus mn less than equal to k, if I just have my focus on this thing, then can I, like does it mean ki this condition will also stay true? Yes, it will definitely stay true, because absolute difference of any other characters, the frequencies of any other characters would definitely be less than or equal to mx minus mn. So we can just focus on keeping mx minus mn being as small as possible. So we can just say our mx is the maximum frequency of any character in this given string, like after removing some characters. Like let's say if I remove b, let's say if I remove c, no. Okay, let's keep it till now. Let's not complicate it. Mx is the maximum frequency of any character in the updated string. Updated string is the new string after removing some elements from it. And similarly, mn is the minimum, right? You have found the maximum and minimum frequencies. Then, since you know that you do, like you don't really know what you did, but you know at the end of the day, the substring became good. Let's say that this, okay, the substring, they have already given it a name. The substring became k special. You don't know what you did, but it became k special. So in that case, like as we had been earlier imagining that we did something, we don't really know what, but it was the best thing. So there also we were having a k special string. And now similarly we have got a k special string. So here you know this thing for a fact that mx minus mn would be less than equal to k. Right. Now tell me one thing. If let's say mx is 7, mn is 4 and k is 5, then in that case it means that the frequencies of all the remaining characters after removing some of the characters in the given string, the frequencies of all the characters in the string is in the range from 4 to 7, right? Does it mean this thing? I'm not really talking about this example right now, I'm just talking in general, that you know that mx minus mn is less than equal to k. You know about, let's say the frequency of mx is 7 and the frequency of mn is 4. In that case you know that the frequency of each and every character in the given string would be in the range from 4 to 7, and this k is 5 here. Then can I say that for this case, in even in that case I can say that the frequency of all the characters in the string would be in the range from 4 to 9? Can I say this thing? I can definitely say this, right? If all the frequencies are in the range from 4 to 7, the frequencies are in the range from 4 to 9 also. This one is having stricter constraints for the given string, that everyone should have the frequencies in this range only. This one is having looser constraints. The constraints here are loose, right? So what I'm trying to say here is, earlier you had earlier you had that a frequency of every character after applying some operation should be either 0 or x. This is something we earlier had. Now what I want to say is, the frequency of every character should either be 0, or it should be in the range from some x, let's say x, from there till x plus k. That's it. um, because you know that the elements will be having some range, their frequencies in some range. So if, if you try to think of any possible solution, let's let's try to think of a solution, uh, maybe like right now trying to wonder how to explain that, why this thing will always work, why this x and x plus k will always work. Let us say you had a5, b2, c7, k equal to 2 here, or maybe k equal to 1 here. You removed b, and you reduced c by 1. So a is 5 and c is 7. You did something like, sorry, c is 6. You did something like this, है ना? Here in this case, your elements, like whatever you did here, at the end of the day, the elements will be in the range, having the frequencies in the range from mn to mx. And this, mn mx is less than equal to mn plus k. So if I say that the elements will be in having their frequencies in the range from mn to mn plus k, I'm still correct, है ना? I'm still not saying anything wrong. And uh, so in a nutshell, if you knew about the mn and mx thing, if you knew about mn and mx, let's say you knew key, you have to make all of these characters come up in the range from mn to mx, as we earlier knew from x, just for the frequency x. Here, like instead of having two cases like these, being greater than x or being less than x, there will be three cases here. If the um, frequency of I is less than mn, then you will remove the character I completely, है ना? If you want the characters to be in the range, they have the frequencies in the range from 5 to 6, then for a character like this one, you will just have to delete it completely. So the cost will be incremented by frequency of I. Else if the frequency is greater than mx, let's say this case c, its frequency is greater than 6, then you will have to increment cost by frequency of I, sorry, yeah, um, yeah, you will have to reduce the frequency, you will have to increase the cost by frequency of I minus mx. That's what you will have to do. And in the other case, if the frequency is in the range from mn to mx, then you don't really have to do anything, है ना? You don't have to do anything. The uh, alphabet is having its frequency in the sweet spot, so you don't really need the else condition here, because in the else condition we are not doing anything. So these are the three possible cases here: the frequency being greater than mx, you reduce it to mx; the frequency being less than mn, you just reduce it completely till 0, and this is a sweet spot. You don't really have to do anything here, है ना? So we have understood here how will you find out the answer for some mn and mx. Now the only doubt, I think that we have covered everything so far. The only doubt remaining is how do you guarantee ki mn and mn plus k, like you get it, you get one thing ki the cost you need to have for putting up the elements in this range from mn to mx would might be greater than this or might be equal to this. Basically if I say yeah, this is the place mx mn plus k, for the case where you are having the range from mn till mn plus k, all the characters which were greater than mx and were in this range, you will not have to apply any operations on them. And for all the elements which are greater than mn plus k, you will have to apply less operations to get this element here instead of getting it here. I think that it is also doable. You should be able to realize key. It might not give me, like it will never give me a bad answer. It will never give me a worse answer than this. So I can definitely say that if I just check out all the ranges, like okay, um, here I don't, yeah, if I just check out all the ranges like these, or maybe say all the ranges like x and x plus k, and try to put up um, these elements, the frequencies of these elements inside this range, then I will get my answer. Like the way I told said it might be a bit ambiguous, but I believe that if you have been till now from the very start, we have actually got everything. So probably you would have realized it. The what do we need to discuss now? Yeah, the only thing which is left to discuss is how will you find out this range? Like you don't really know about the value of mn, you only know about the value of k. So how many possible values are there? Earlier for x, the possible values were, if you remember about x, the possible values were 0, 1, 2, 3, and so on till n. Here for the range from x till x plus k, the possible values are from 0 to k, 0 to k plus 1, sorry, 1 to k plus 1, 2 to k plus 2, and so on till n minus k till n. You have only a few, like these are not even n number of possible ranges. You just have to check for each and every range one by one, that what will be the cost to have all the frequencies of all the characters come up either in this range or become zero. And every time just find out the cost and say your answer is equal to minimum of answer and cost. Now I believe that I might have explained too much, but it should not be like it should not be in a way ki I missed out something. I hope that everything has been discussed for this problem, and it is a bit doable now. Like it's completely doable actually. It's now doable. Even if you don't look at the implementation, it should be doable. Uh, Nevertheless, I will show you my implementation. This is the C problem. Yep. So here what I did is, first of all, I calculated the frequency of each and every character in the string in this way. And after that, for each and every possible value of, instead of saying x, I have been calling it as mn. Like I just ran up a loop of mn from 0 to mn is less than n. Obviously, if you want, you could have stopped at less than equal to n minus k, but it's not really a problem even if you run up completely. You're just talking about some additional cases which won't create any difference. And every time for this, like instead of saying mn plus k every time, I just called it as mx. I just said here I will have mx equal to mn plus k. And I did go up for each and every character. I have only 26 characters in the string. I calculated the frequency every time. I calculated the frequency every time. Uh, sorry, I have already calculated the frequency. I just checked whether the frequency is less than mn or not. If it is less than mn, then it means that I have to delete all the occurrences of that character. So I will increase cost by fric I. Otherwise, if the frequency is greater than mx, then I will reduce the frequency by frequency minus mx number of times, so that the frequency becomes equal to mx. Basically, the cost will be incremented by frequency of I minus mx number of mx value, because that is the number of extra elements I have. And in the other case, I don't really have to do anything. The cost is already fine, so I just did not write any else condition here. And at the end, we are just saying our answer is equal to minimum of answer and cost. And at the end, we just returned the answer. Now, the time complexity here will be big O of n. So we are having big O of n plus this is having a for loop of big O of n size, and um, this is having a big O of 26, like basically constant, almost constant time complexity. It is big O of 26 into n. Some people might like to ignore it, but I wouldn't ignore it right now. And we used almost constant space. The space we have used is just 26, which is almost constant. So that's it. The time and space complexities are like this. We will call it as linear time and constant space. So now let's come to the fourth problem. This is the fourth problem. It was not solved by so many people. Like, it has very less submissions today. Um, the problem says minimum moves to pick k ones. Um, we have been given a zero indexed binary array nums of length n and a positive integer k and a non-negative integer max changes. On k is positive. Yep, k is positive and max changes will be greater than equal to 0. Dylan Smith plays a game where the goal is for Dylan to pick up k ones from the nums using the minimum number of moves. So you know that this given array was binary array. It will have either a 0 or a 1. Dylan's goal is to pick up k ones from nums using minimum number of moves. When the game starts, Dylan picks up any index, let's call it as Dylan index, in the range from 0 to n minus 1 and stands there. Now, if Dylan's index is if nums of Dylan index is equal to 0, if there is a 1 at that place, Dylan will pick up the 1 and nums of Dylan index will now become 0, and this does not count as a move. Right now we have not used any move. After this, Dylan can make any number of moves including 0, where in each move Dylan must perform exactly one of the following operations. Select an index j which is not equal to Dylan index such that nums j is 0 and set nums j equal to 1. This operation can be performed at max changes number of times. So basically, choose any index other than the index at which Dylan has been standing. Choose any index other than it, which is 0 right now, and set the value equal to 1. And in the other operation, like the other operation which Dylan can perform is, or sorry, the other action which he or she can perform is, um, select two adjacent indices x and y such that their absolute difference is equal to 1. Basically, one of them should be 1 and the other one should be equal to 0. Such that, okay, they have actually said, sorry, um, two adjacent indices x and y. Basically, both of, yeah, this is just the formal way of saying that x and y are adjacent, such that nums of x is 1 and nums of y is 0. The first index you chose, like the index you chose as x is 1 and the other index is 0. Then swap their values basically set nums y equal to 1 and nums x equal to 0. And if y is equal to dial n x, sorry, dial n index, basically the character, the index at which you place the one now is dial n's index, then dial n will pick up the one after this move and nums y will become equal to 0, and we have to return the minimum number of moves required by dial n to pick up exactly k ones. Yeah, so this is the problem. Now let me tell you about it in brief here. You have been given an array. This is an array. The array contains either zeros or ones. Like the every element would either be a zero or a one. And first of all, dial n will choose an index. Let's call it as dial n index. He will choose any index in the given array. If there is a one there, like dial n had to pick up k ones. If you get a one there, then you will just reduce k by one, and like now you want to pick up k minus one number of ones, and it will have a zero here. It did not cost it did not have any cost till now. You have not used any operation so far. Now what you can do is you can pick up any j in the given array other than the dial index, and you have two possible choices for you have two type of moves. One of the actions, like in one move, one of the actions which you can perform is pick up any zero other than the index on which dial like other than this element, pick up any zero in the given array and make it equal to 1. Like just pick up any place which is 0 and make it equal to 1. So it will, like here you just have to choose a j that is not equal to dial index and set nums of j equal to 1. Now tell me one thing. Let's say, yeah, one more thing. It will reduce the integer max changes by 1. It will reduce that count by 1. This is some integer being given to you, and it tells you the number of times you can place a 1 at some place from a 0. And the other kind of operation which you can perform is pick up an index. Let's call it as x, maybe not this one, but let's say if a 1 is at some place and there is a 0 at some place, choose some x such that nums of x is 1, choose its adjacent such that nums of y, like the adjacent cell, is 0, and x and y are adjacent. For that you can just say that absolute difference between x and y is equal to 1, and swap these values. So in that case, you will have 1 here and 0 here. This is the other operation which we can perform. Swap 0 and 1. Swap a 0 and a 1. Okay. Now what you want to do is, let's say if there was a 1 at this place and you had chosen this as x and this as y and you had swapped these places, you will get a 0 here and you will get a 1 here. Dial will pick up this 1 and set up a 0 here once again. He will set up a 0 here once again. And if you realize, this is the only way in which you can have dial and pick up ones. One of the ways of for dial and to pick up a 1 is by sitting up at some index which already has a 1. So one of the ways for dial and to choose 1 is sit up on an index which already has a 1. And the other way is choose, like if this is the dial index, and like let me draw dial index with blue pen. The other way is you have a 0 at this place, have a 1 at the neighbor place and swap these. How will you get a 1 at the neighbor place? maybe you had a 0 here and you had a 1 at some place, you swapped it multiple times to get the 1 till here, or maybe you used the first kind of operation to get a 1 here. In any case you do, for having dialin to pick up a 1, you need that 1 to first of all reach to a neighbor, and then you can perform the second kind of operation to feed dialin a 1, right? So we have seen here, if you want dialin to get a 1, you need its neighbor to have 1. Now, for now, let's forget about this kind of an operation, the one kind of operation, and only talk about the second kind of operation. If this is the Dylan's index, and there is a 1 here, there is a 1 here, and there is a 1 here. The problem told you about a condition that when you want to swap two numbers, you want both of them to be different. Like you want one of them to be 1 and the other one to be 0. Do you think that it really matters? If the problem had given us the freedom of choosing two elements with the same value, will you still make a swap? Like let's say that they don't really give you this condition of nums x and y to be in this way. You only need x and y to be adjacent, and you can perform operation here. Will you perform any operation there if both of these elements are equal? No, you will never make the operation, because if you swap these two ones together, your array will still remain the same. Nothing changed. You just got the number of moves being incremented by 1. So you just got to a worse condition. है ना? You just used a move which will never benefit you. So you see that the condition they had given you does not really matter much. The only thing is, even if they had said that you can make swaps, you can swap alternate like adjacent elements. You can swap adjacent elements. Even if the condition was this much, your answer will still be the same. So let's only talk about this guy. Like I won't say these conditions again and again because it is obvious. We will never, like even if we were permitted, we would have never chosen it. Now the other case is, if there is a 0 and there is a 1 here, or if we talk about this case, 1 here, 0 here, would it be beneficial for me to swap these two? Definitely no. What I want is, I want the ones to come closer to Dylan. Getting it away will only make things worse, right? Let me do one more thing. Let's have a 1 here also. Now tell me, if Dylan needs only 1, like if value of k here is only 1, let's say if you have chosen this Dylan index, and now you know that you want only one more 1, like you know need only one more element whose value is equal to 1 to get to Dylan. Should you make these swaps or should you make these swaps? I think it's obvious. The one which is closer, it will reach here first, earlier. So like it will reach there in minimum number of steps. So it makes more sense to um, swap it like this. Huh? So you will just search for the closest one. So if you had like if you require maybe yeah, let's say if k was equal to 3, then what would you do is, this guy and this guy, you will just take these ones to Dylan, and the cost of taking it, like if you talk about this one, its cost to reach to Dylan is nothing but it is actually equal to, like the number of swaps you will require to make is nothing but the absolute difference between the index of Dylan's index and the index where 1 is present, right? So for like you will first of all check for the closest one. You found this. It is at a distance of 1. So your answer became equal to like 0, 1 being added. Then the closest one is this one at a distance of 2. So you got 2 being incremented. Then you have this guy and like one, two, three, and yeah, you are having these two people, like either this guy or this guy. These two are at the distances of three. Pick up any one of them, it doesn't really matter. Pick up this one. Now K, the requirement of K has been satisfied. If it had not been satisfied, then you would have required more. But for now, since it has been satisfied, you will say your answer is equal to 6. That's it. If you required more, then this would have been the next element, then this would have been the next element, and so on. Right. But right now we did not talk about the change, like max change variable. There was a variable with the max change, I guess. Yeah, max changes. Let us say max changes. This variable is equal to 2. Tell me one thing. Should I make 3 swaps? Let me raise it a bit. Okay, the first question is, if I can use this max change thing, where should I insert a 1? Should I insert a 1 here at the edge of the array? No. It will, like, the closer, like you want the ones to be as close as possible to dial. So it makes sense here. First of all, first of all, you will dial will pick up the one, like pick up a one if it is at this index, like wherever dial is. If there is a one at this index, then dial will just pick it up. Then, like the first thing which dial will do is this guy only. If there is a one, just pick it up. Then, if dial requires more ones and there is a one here, then dial will pick up this one, right? Because it is having a cost of only one. Cost is only one here if you pick up a neighbor. Similarly for this guy, Dylan will check here also. Here, if the neighbors have ones and I require them, then I can just get these ones with a cost of 1. After this, the elements which are at the distances of 2, I can get them with a cost of 2. Similarly, I can get these ones which are not really present in the array right now, but I can use the operation of type 1, the action of type 1, like the kind type 1 move, to get a 1 at this place, to bring a 1 at this place, and then swap it. It will have costs of 2's, right? So for Dylan, you can get elements with a cost of 0 uh, at the Dylan index, whatever element is present at Dylan index, just pick it up because it is having a cost of 0. Then the neighbors have a cost of 1. So just pick up the neighbors. Then the neighbors with distance 2, or the max change, like the number of times you can max change, basically the number of times you can change the elements from 0 to 1. Again, the problem said that you can change the element only from 0 to 1, but even if they had said that you can change element from anything to anything, you would still perform the operation only from 0 to 1. So the problem was just making things look a bit, I think that they made the problem a little simpler maybe. um, Anyways, it doesn't really matter. Let's come back. Dylan's first priority will be to pick up the one at the Dylan index. Then, if he requires more ones, then he will look at the neighbors, the direct neighbors, adjacent elements basically. If he requires even more, then he will look up for the max change moves, basically use those moves because it every time it will have a cost of 2, and then every time it will have a cost of x for every one at a distance of x. Like for everyone which is at a distance of x, the cost will be equal to x. So you would try to add up, like you will try to pick up the ones which are closer one, right, which are closer. Now from here onwards, um, the way you will find out, like what one thing is clear, if you fix up dial and index, you can definitely find out the minimum number of moves minimum number of moves for Dylan to get K1s. If you know about the Dylan index, since we don't really know about the most optimal Dylan index, like as we did in the third problem, we can just brute force this thing. We can say that hey, Dylan index can start from 0 till n minus 1. For each and every one of them, you can just you can just run up a for loop here, and after that, here you can just find out the minimum cost, like initialize cost with 0, find out the cost somehow, find the cost, and then say your answer equal to min of answer and cost. Right? You can do something like this as we did in the third problem. Like we had a very similar idea that right now we don't know which Dylan index we will pick, but if we knew like if Dylan index this thing is fixed, then we can find out what will be the minimum cost required. So we can just fix its value one by one for all 0 to n minus 1. And how will you find out the cost for a specific Dylan index? You can just find it in like very easily by checking up on the left and right side to find out the closest one. It will have a time complexity of big of n, I guess. Every time you have to pick up, like for every Dylan index, the cost will be big of n. Like this thing will be done in big of 1. This thing will be done in big of 1. This thing will also be done in big of 1 because you already know about the count. But for this part, if you don't do any pre-computation, then you will have to do big of n time. You will have to search for the entire array. But one thing, like now, we can't make any optimizations here, here, or here. We can make optimizations only here. This is not really good. So you will try to think of some better way of finding out the closest ones, right? Now our goal has been shifted. It is like we know some index. Let us say the index is idx for now. Like we know about some specific index, and now what we want to do is like we will have some index, maybe r, let's say req, that is just the short name of required, that required number of more ones you need. You might be given something like this, and you will have to find out the um, okay, one more thing. If you see, you are actually increasing the distance from this place one by one. Like first of all, you were searching only in this range, then you were searching in this range, then you were searching in this range because all the elements at a distance of 2's, then the elements with a distance of 3, if you remember, like we had been doing it in this way, then distance 4, then distance 5, and so on. So if I just say instead of uh, finding out the number of elements in these ranges one by one, instead of having the search linearly, what if I apply a binary search here? What if I apply a binary search here and directly say, please, like instead of first of all finding out the number of ones in this range, then the number of ones in this range, then the number of ones in this range, and so on. What if I directly say, tell me about the number of ones in this range? How can you find out the number of ones in a range? Obviously, we can do some pre-computation. We can, like, there are multiple ways of doing it. One of the possible ways is that maybe you can just find out, um, let us say this thing as mid, basically the distance as mid. So you know about the starting index, like sorry, you know about the center, you know about this index. You like when you are applying a binary search on this distance value, so with the help of that you will know about the starting index. Let me call this thing as left, and similarly you will know about 1 2 3 1 2 3, yeah. This is the ending, yeah. Similarly you will just find out the right index, and you want to just find out the number of ones in this range, basically the sum of all the elements in this range, because every element is either 0 or 1. So if you just figure out the sum of all the elements in this range, you will know about the number of ones in the range. right? You can just do something like this. So I'm not really showing you how to do it. I expect that if you are coming up for a problem like this one, you know about prefix sum arrays and range queries and all. You can simply create a prefix sum array. You can create a prefix sum array and apply, uh, just check out pre of right minus pre of left minus 1 to find out the number of elements in this range. Remember, remember one thing, that we have already picked up these elements. We have already picked up these elements. So, so this prefix sum would actually tell you about these people also. The element on the dial index if it was one, and the elements on the neighbors if they were also one. It would count those as well. So at the time when you were taking them, it's a good idea to just keep track of how many elements you have taken out of these, so that you can just check out the number of total elements in this range and subtract the number of elements you have already taken. So you will get the count of the number of elements in this range which you have not taken so far. So in this way, you can have a binary search. So you will have login, like you will check for login ranges, like you will check for ranges login number of times. Basically, you search for this. Let us say you got, let us say you in this range got CNT number of elements which have not been chosen so far, CNT number of ones which have not been chosen so far. If this CNT is greater than or equal to rec, then you will just set kr. I will now search in for a smaller value of mid. We will just search for a smaller value of mid by saying something like end equal to mid minus 1. Start and mid are the values of this mid, or we will like for the implementation purpose, it depends upon how you define that mid, start, and end, like all that stuff. Basically, we will search for a smaller range, and in case if count was less than week, then in that case you will search for a larger range. So the idea is you would have got the value of mid, which will tell you about the distance, the maximum, this like um, yeah, this the smallest range, such that it contains at least strict number of new elements. Let us say you got it to be something like this. You had the mid value here. You had the center here. This is your index, basically Xylan index, Dylan index, and let's say you got the mid value to be something like this. So you know that you now have to, and you know one more thing, that you have already picked up. Um, these elements have already been picked up, right? These have already been picked up. So idx minus 1 and idx plus 1 have also been picked up. Now what you want to do is you just want to find out the elements which are in this range, for all the elements which are in this range and for all the elements which are in this range, their cost, like the sum of distances to all of those ones in these ranges, right? You would have got some starting point, let's say left, and some ending point, let's say right here, and you know that this guy is nothing but idx minus 2 and this guy is nothing but idx plus 2. Finding out this is not really that hard, but for doing this, what I did is I just kept track, like for the whole array I just kept track of all the indices where one is coming. Let us say it is having something like 0 1 1 0, like whatever. Let's say index 7 and 8. Let's say that 1 is coming at index 7 and 8. Then inside some array, for the whole array I've just created an array with name, let's say ones, and there I had put up the indices where the element 1 is coming up, and like this range which I have to search for, I just had calculated, um, maybe you can just create a prefix array, like for this thing. I did actually create a prefix array as well. I did create a prefix array, prefix sum array, like other than this one. For this I didn't create a prefix array, I did create for this one. I did it in a different lower bound and upper bound stuff, but it can be done with prefix sum also. Coming back to this, what I did is, in the normal prefix sum array, what we were doing is just keeping track of the sum of the elements. Like, let me take a different example. I will discuss this in a little later. I think we will otherwise get too far away from what we have to do. Let's come back to the place where we were. First of all, Dylan took the ones here. Then Dylan took the ones on these two positions, which were the neighbors. They had a cost. They had the costs of ones, and like at any step, whenever Dinah is having the required number of ones being completed, she won't or he won't take up any more ones. But till that place, first of all, Dinah will search here. Then he will look up for this place. After that, Dylan will look up for all the max change operations. Like, will look up, basically he will look up for adding up a one here and then swapping it here in this way, because it will every time have a cost of two, one a cost of one for adding a one at the neighbor adjacent place, and a cost of one for swapping it. So it would be in this way. After that, Dylan will have to pick up some more ones. So for that, we used binary search to find out the range, the range in which, apart from these cells, apart from these elements, these plus these elements are also having required number of ones. Let's say if you required k number of ones, maybe if you required 10 number of ones, you got a one at Dinah's place, you got a one at neighbor's place, one of the neighbors had a one, the other one did not have. Let's say something like this happened. You had max change was having maybe, let's say, value 3, you got 3 more ones, you required 5 more ones. So what we have now in this range is, apart from these positions, you require 5 more ones in these places. So we just got this kind of a range using binary search. It will have either 5 or more number of ones. It is possible that the corners positions are actually having 1 1. Let us say you required 5 number of ones, and like, this smaller range was having 4 number of ones and the larger range is having 6 number of ones. So yeah, this thing is completely possible and it can be easily handled later on. The idea is, now the only thing which you need to do is, what you want to find out the sum of distances of all these ones from this person, right? So for that, what you can do is, you know that there are 3 ones in this range, so you can say, 3 into idx minus the sum of all of these indices, like sum idx, like the sum idx 6 comma 9 will have the sum of all the indices of the elements which have 1 as their values in the range from 6 to 9. So you can do something like this to get the sum of distances of all the elements in this range from this current guy. We got this formula because you know that what we are doing is idx minus the index of this 8, idx minus 7, idx minus 6, right? Idx minus the index of first one, idx minus the index of second one, idx minus the index of third one. We just were doing something like this. So I just called it as the number of times, the number of elements there are, that many times you will have idx minus something. So 3 into idx minus the sum of indices of all of these values. This is a standard problem, a very simple one, a very standard thing. I believe that you should know about it. I'm not really going to explain it even more here. This is a sub problem. Like, if you are not able to do it right now, think about it right now. Just think of it like this, that you will have some index, you will have some zeros and ones in the given array, and what you need to do is, you just have to tell the sum of distances of this index to all the indices which are having 1. This is a sub problem. It is a standard one. Try to solve it first, and then we just have to do the exact same thing here for this guy. And for this guy, it would be in the other way. Sum of if the indices are from, let's say, 12 to 16, then some idx some idx from 12 to 16 minus 3 into idx, considering that there are three ones coming up in this range. So Hannah, you will have something like that. And at the end, the edge case I was talking about, that what if, let me take just a simple example, k is equal to, let's say, 4. No, let's say k is equal to 3, and the array is, let's say, looking something like this. The neighbors of Diana are having 1 1. You will have the required number being reduced to 1. Let's say max changes is 0. Max changes value of that is just 0 for now. So now you will search up for a range to get at least one value of 1. You will get this range, right? You will get this range. So here you see that you got two ones. You required one, but you got one extra. So do the exact same thing which we were doing earlier. Get the cost, basically the sum of distances of all the ones from idx inside this range, other than these ones, other than these. And after that, um, just like, you know that you have got one extra one, you can easily check it out by checking the number of ones in the range and the number of required ones. If you have been getting one extra one, then just like, if this is the distance between these two elements, that is 2 here, whatever cost you got from there, just reduce that distance you had got, that largest maximum distance you had got. For me, in my case, I was calling it as radius, so I just reduced call radius from um cost, basically whatever thing you had got from the binary search, that the maximum distance from this index, just reduce it by 1. So you just got rid of the this distance. So now you are having only like, in the cost, you are not including this one. That's what we wanted. Okay, now I completely agree that the solution is not gonna be 100% clear by just listening. You might have a lot of doubts. This is actually an implementation heavy problem. The logic was not really that hard. It is kind of an implementation heavy problem. You will have to put up efforts by yourself only then you will be able to solve. This is something I can't really explain completely, but I believe that this problem is completely doable now. If you, like, I covered up all the cases, so if you just take up hints and uh, every time you, if whenever you get stuck, if you just take up the hint of what we have to do next and try to identify how to implement it on your own, then you should be able to do it. And I will show you my implementation, but it's a bit complicated, so I won't really explain it completely. I believe that understanding my implementation is gonna be hard. It would be easier to implement it in your way, because understanding someone else's implementation is a hard job. Um, I wrote everything inside a single function. If you want, you can write complete different functions, and you see that the code is quite huge. I created a ones array in which I just pushed up the indices of all the ones. I created a prefix sum array in which, in case if the element is 1, only then I'm adding the index of the element, else I'm not adding anything, because I will use this thing for getting the sum of distances to all the things, that sum idx thing for that. And instead of having this function with name sum idx, I have it with the name get idx. I'm having a few checks because, like, I think that this case will never happen, but having the checks was not really a problem, so I just use those checks, that in case if I'm having a negative value of L, which should never be the case, then just mark it as 0, or if R is greater than equal to n, then just mark it equal to n minus 1. If L is greater than R, in that case, just have it as 0. This case can happen, but these cases I don't think will ever happen. And having the case like, or maybe actually these can also happen. These can also happen. I wrote it at some place. Yeah, basically it will give me the sum of indices of all the elements in the range from L to R such that their value is actually greater than equal to 1. Since I wanted to have a very small, like find out the minimum possible value for answer, I initialized it with a very large value. I created a function with name getCount in which I will pass on the indices of the original array, and it will tell me the number of elements, the number of ones in the range from left to right, from the index left to the index right. I did it in this way. If you want, you can use prefix sum array or whatever. Um, like if you create a prefix sum array, it will have a better time complexity. Instead of running up a lower bound, upper bound, you will just have a big O of one time for answering it. And here I'm having a find radius function, which we will see later on. Um, for each and every index, I'm considering it as the dial index. I'm initializing the cost with 0. The required number of ones which I have to pick up is gonna be k for everyone initially, and I have kept track of the number of ones. Like I have initialized a variable with name taken equal to 0, which which will keep track of the number of ones I have picked up from the dial index and the adjacent neighbor. So I have kept nums I equal to 1, ric minus minus, because like if there is a 1 here, then the required number of ones would be reduced and the taken number of 1 from these three elements would be increased. Then I'm checking for the neighbors. I'm having a condition if ric is greater than 0 here. If you want, you could have applied here also, but I know that k is always positive, so it would definitely be greater than 0, so it's not really useful to apply the condition there. But here it's important. It is possible that if k was equal to 1, then you might have got ric equal to 0 there. So here I am checking if ric is greater than 0, the left neighbor exists and the left neighbor is having a value 1. In that case, increase the cost by 1, reduce the number of required ones, and increase the value of taken by 1. Similarly for the right neighbor. And after that, in case if I need even more neighbors, if I need even more ones, then check the number of ones. Like see, you don't want to uh, here this op is storing the number of moves. I would use in this way, like that cost we talked about, like this way we talked about key. If this is the dial index, you have picked up the neighbors. Like this is the dial index, you have picked up the neighbors. Now use the operation of max changes to make a one here and then swap, है ना? The combination of two operations in a row, you will, like you need a cost of 2 to get the request reduced by 1, right? So I just said yeah, find out the number of times I need to use the request. In case if the need is less, or the number of operations I can perform, whatever is the minimum one of them, I will apply that many operations. It will reduce the required number of ones by that much amount and increase the cost by 2 into operations, because every operation was having a cost of 2. After that, if I'm still having a requirement of ones, I will find this radius. The procedure of finding this radius is just simple binary search. A simple binary search to check, get some distance, that till which uh, distance you like, just find out the smallest range which will have count the number of elements there being greater than or equal to required number of ones. So I'm just finding out radius here. For finding out radius, I'm having a binary search. Start equal to 0 and equal to n minus 1. The smallest range might be 0, which will actually never be the case because I will need at least one element. And uh, I'm initializing the result with n minus 1, that is the worst case. While start is less than equal to end, I'm just simply having a normal binary search. I'm having like, let's say if mid is the mid is this radius, like if this is the radius, then I'm finding out the left pointer, the right pointer. These are the left and right pointers I have found out. And after that, I'm finding out the number of elements in this range that will be found by using the get count function which I had created here. I'm using upper bound lower bound functions for that. And from that, I'm reducing the number of elements I have already picked up in the neighbor and the dial and index. After that, I'm saying here, in case if the count is greater than equal to requirement, then it's fine. Just store this mit in result, which I will return at the end, and reduce the radius. Otherwise, increase the radius if the number of elements are not complete there. So just 1 minute. And after that, uh, I'm having the left index and right index being found. Like this is the exact same thing which I would have found here. I'm just finding it again, calculating it again after getting the radius. Because now I know that this is the range, like you have found the range. So now you want to find out the number of the sum of all the elements in this range. Oh yeah, before that, I'm like, it can be done in less number of lines, but I was having some bug. By mistake, I had here, instead of writing I had written nums of I, which was incorrect. So because of the bug, I had to write up so many C out lines. For that, I wrote so many lines here, but it can be written in less number of lines also. Just 1 minute. Uh, yeah. So here the thing is, um, I'm having the number of elements in the left range and the right range using the get count function. I'm finding out the cost of the left range and the right range of basically the sum of distances of the left range and the right range. And then I've been adding that cost, and I've been reducing the required number of elements by the number of elements I found on the left and the right. In case if the requirement goes below zero, which means that I have like I have found the cost for one extra element, that edge case we had been talking about. What if there are one and one at this place, and like this range has one less element and this range has one extra element? So this is just taking care of that edge case. And at the end, the requirement should have been equal to zero. I did write up a line as a trick equal to zero, which will give me a runtime error in case if requirement was not zero. If it had been anything other than zero, then it should give me a runtime error so that I will know that I have done some mistake somewhere. Um, and at the end, I'm just saying, yeah, answer is equal to minimum of answer and cost, and then I returned the answer. So yeah, that's it. The problem got too complicated, I guess. Like the implementation got too complicated. And yeah, the problem is actually hard as well. You see that, like not hard, but really complicated, complex. The problem is complex. That's why it is having very less number of total accepted, even though so many people try to submit, like 300 submissions and only 196 accepted. So I hope that this solution, like this editorial, helped you out to absolve. And in case if it did, then please consider liking the video, and please make sure to give your honest feedback in the comment section. I would be really happy to see your feedback. And please tell me about it, whether you guys want me to explain in a lot of depth like this editorial, or you guys want me to make smaller videos. I think that larger videos are better because you can just skip the part which you already understood. But tell me whatever you want me to make, like in what way you want me to make the videos in future. And thank you for watching the video. Bye bye.